Hello everyone. This video is on section 8.4 part 1. It's titled Add and Subtract Radical Expressions. Right, and when you see the word radical, right, that means roots, square roots, cube roots, etc. In this video, I'm going to be going over a version of your Knewton Alta assignment for section 8.4 part 1. Please understand that the version you're going to see me do in this video may or may not be exactly the same questions that you see when you do it on your own. But the objectives are the same, the types of questions are similar, how I would go about working on those or how you should go about working on them should be similar. So I'm hoping that watching me do these here help you in some way when you're working on the assignment on your own. Right, so here's the assignment page. At the top, again, you won't be seeing the word preview of. You'll just see the title of the assignment, the mastery bar, right, telling you how far along you've gotten, the objectives, which it looks like there's only one objective here in this section 8.4 part 1 assignment. It's add and subtract radical expressions. And then you have your questions, and below every question there should be a feedback button where you can send Knewton some feedback if you wish. You will not see the instructor cheat button, right? That's for instructors only. But you will see the more instruction button. And I recommend use of this whenever you come across a new objective or you're struggling with a problem in a certain objective. If you click on the more instruction button, you'll be provided with extra reading material or videos or both that will hopefully help you in that particular objective. Alright, so as I said, pardon me, there's only the one objective here, add and subtract radical expressions. And my first question involves cube roots and adding. Right? So let's pull this up on some paper and get to it. Alright, so this first question we have 5 times. Remember, if there's nothing between stuff and they're just touching, that's like multiplication. 5 times, then you have the cube root of 1250 plus, and then 7 times the cube root of 270. Now, we're talking about adding and subtracting radical expressions here. Notice that the roots, right, both these roots, the cube root of 1250, the cube root of 270, have different radicands. And remember, the radicand is just the expression that's inside the symbol, inside the square root. You can only add or subtract, and I'll make that note off to the side here. You can only add or subtract or combine, you can only add or subtract slash, combine. When I say add and subtract, another way they might shorten that is by saying combine like radicals. Okay, and what are like radicals? Okay, like radicals. 1, they're radicals that have the same index. Okay, so looking at these two radical terms here, they have the same index. Remember, the index is what the root is, the number in that little crook of the symbol. So this radical term has an index of 3, so does this radical term. Right? So they're both cube roots. That's fine. But also, right, and they have the same index, and they must have the same radicand, which these do not. Right? This has a radicand of 1250. This has a radicand of 270. Right? So right now I can't add these together the way they look. I can't combine them. So what we need to do, we need to simplify the radical terms. Right? Now we have seen videos before on simplifying radicals, or at least I've made videos before. Hopefully you've been following. And I'm also assuming you've done some reading and studying of the material before you're watching these. Let's simplify the radicals first. So I'll start with the cube root of 1250. Now remember, this is a cube root, so I'm looking for perfect cubes. Now I can see right away a perfect cube that is a factor of 1250, and that would be 125. And I'm going to use the product property here to break this up to the cube root of 125 multiplied by the cube root of 10. Right, using the product property for radicals that I'm assuming you know by now. Because 125 is 5 cubed. Right, this is the cube root of 5 cubed. This should just be 5. So we have the cube root of 1250 is 5 times the cube root of 10, right? And that's as simple as that gets, because 10 doesn't have any perfect cube factors. Right? 10 is 2 to the first times 5 to the first. There is no factor of 10 that's a perfect third power, a perfect cube. And then similarly for the cube root of 270. Now once again, you can factor this completely, right? Go back to my videos on simplifying radicals. But I'm seeing right away that, a factor of 270 that's a perfect cube is 27. 27 is 3 cubed. So once again, using the product property, I'm going to break this up to the cube root of 27 times the cube root of 10. And the cube root of 27 is 3. All right, so this ends up simplifying to 3 times the cube root of 10. All right, and now I'll put these into the expression. And we're going to see some terms that have what are called like radicals. So finally, I'll bring this expression down here, right? This is equal to 5 times, right? 5 times, then the cube root of 1250 we saw is just 5 times the cube root of 10. Then we have plus, right? Plus, and then next term, we have 7 times, and then the cube root of 270 we saw is 3 times the cube root of 10. And, multiplying the numbers together, the numbers outside the radicals. 5 times 5 is 25, so that first term is 25 cube roots of 10. All right, 25 times the cube root of 10, plus, and then 7 times 3 is 21. Then we have 21 cube roots of 10, right? 21 times the cube root of 10. And now look at these radicals in each of these terms. They have the same index, and they have the same radicand, right? They're both the cube root of 10. So these terms here are like radicals, meaning I can combine them. And it's just like combining like terms. It's just like having 25x plus 21x, where instead of x, you have this cube root of 10. Remember, 25x plus 21x would be 46x. You could also think about it as factoring out a common factor, right? Both these have a common factor of the cube root of 10. And if I were to pull that out, factor out a cube root of 10, And if you factor out a cube root of 10, what's left over is 25 plus 21. All you're doing is combining the coefficients of the radicals to make a new radical. And we got 46 times the cube root of 10. And this is as simple as we can get. And this is what they're asking us to do. All right. And let's double check. All right, let's double check. So what I'm going to do is I'm going to pull up a calculator here, and I'm going to enter my initial expression, right, that was given to me. We were given 5 times the cube root of 1,250 plus, and then 7 times the cube root of 270. And we get this number here, 99.10399574, blah, blah. It goes on forever. Well, now, let me enter what we ended up with after totally simplifying, right? Simplifying the radicals and then combining these like radicals, right? I ended up with 46 times the cube root of 10. Let me see if that gives me the same number, and it should if I did things correctly. So I'm entering 46 times the cube root of 10. And look at that, right? It's exactly the same number. And they should be, right? If you're doing everything correctly, the expression in the beginning and the expression at the end should have the same value. Okay, so let's go back and enter that. Get rid of the calculator page there. And yeah, they just want you to enter the simplified result, 46 times the cube root, right? I need 3 in the index, 10 in the radicand, the cube root of 10, right? Just like that, 46 right next to the cube root of 10, submit, and wonderful. All right, and at the end of every question, there should be, whether you get it right or wrong, right, there should be an answer explanation. Right. I highly recommend reading through these, whether you got it right or wrong. If you got it right, read through it just to make sure that you got it right for the right reasons. Or maybe they did it in an alternate way that you find easier and might use for future questions. Now, if you got it wrong, definitely read the answer explanations, right? Try to figure out where you went wrong, why you were wrong, and see if you can learn from your mistakes for future questions. Alright, so let's continue on. Next question in this same objective. It's the same thing, only with, variables. Right? There are some variables here. Alright, so I'm going to write this out, and you're going to see that there's nothing we can do here. Alright, the way they gave it to us, is as simplified as it gets. Alright, and I'll show you. Alright, so for this question, we're given 8 times the 6th root of 5x minus 3 times the cube root of 3y. These are not like radicals. I'll just say not like. For 2 reasons. They have a different index, right? 6 and 3. This is a 6th root. This is a cube root. And they also have different radicands, 5x and 3y. Also, the radicals are already totally simplified. The 6th root of 5x can't be simplified any further. There are no factors of 5 times x that are 6th powers. Over here, same thing, the cube root of 3y. 3y has no factors that are perfect cubes. So this is as simple as it gets. This is what I'm going to enter. I'm just going to, you can't combine these. I can't do anything. And the radicals are already simplified. This is as far as we can go. Now you could, use the fact that cube root is to the 1/3 power and then change this to the 6th root of 9y squared and say, oh, they're both 6 roots now, but then the radicands wouldn't be the same. I can't see any way to make these like radicals, to give these terms the same index and the same radicand. So back in the assignment, I'm just going to simply enter what they gave me. 8 times the 6th root of 5x minus, and then 3 times the cube root of 3y. Just exactly what they gave me is already as simple as that's going to get. See? And once again, please, see they mentioned the radicals are not like, we can't combine them. So you leave the expression as is. Okay, great. Next question. So another one where we're asked to, combine radicals, but the way they're given, the radicals are not like. Right? One term has the square root of 98 attached to it, and the second term here has the square root of 72. So they're not like. They have the same. They're both the same root, right? They're both square roots. That's good. But they have different radicands, right? 98 and 72 are not the same. So I can't put these together right now. Right? So once again, I'm going to write this out and we'll do it on paper. Okay, so I'm given 1/2 times the square root of 98 minus 6 times the square root of 72. Alright, once again off to the side here, I'm going to simplify the radicals. Right? Square root of 98. Now be careful, right? Before we did cube roots, this is a square root. So I'm looking for factors of 98 that are a perfect square. Well, 49, again, you can break it down completely, but I can see it right now. Right? This is the square root of 49 times the square root of 2, right? Using that product property. And the square root of 49 is just 7. Right? Remember, when you see the even root symbol, they want the non-negative root. So there's positive 7 times the square root of 2. Right, so we end up here with 7 times the square root of 2 is the simplification of the square root of 98. The other radical I'm seeing is the square root of 72. Once again, I'm looking for perfect squares that are a factor of 72, and that would be 36. Right? So break this up to the square root of 36, which is 6 squared, times the square root of 2. Right? There's the square root of 72. Square root of 36 is 6. Right? So we have 6 times the square root of 2 for that. Alright, so now I'm putting these, right, the 7 times the square root of 2 and the 6 times the square root of 2, I'm putting these back into my expression here. So this expression we were given is now 1/2 times, and then the square root of 98 is 7 times the square root of 2. Minus, and then 6 times the square root of 72 is 6 times the square root of 2. Multiplying the numbers, we can do that, right? Now, 1/2 times 7 is just 7/2. So we have 7/2 times the square root of 2, minus, and then 6 times 6 is 36. Right, so 36 times the square root of 2. And now both of these have the square root of 2 in common. You can factor that out and just combine the numbers. Right? I'm pulling out, factoring out the square root of 2, and the other factor would be 7/2 minus 36. Now you got to remember, when you add or subtract, you need a common denominator when you add and subtract numbers, right? This is like 36 over 1. So I need to multiply this by 2 over 2. Right? So what I end up with here is, a denominator of 2 from this. All right, when you get a common denominator, that denominator is the result of the subtraction or addition. And then you combine the numerators, right? So you have the numerator 7 minus, and then 2 times 36 is 72. 7 minus 72 would be negative 65. Right? 7 minus 72, which is just the opposite of 72 minus 7. So negative 65 halves times the square root of 2, right? You still have this factor of the square root of 2 here, and this is it. That's as simple as that's getting. And that's what we're going to have enter. And also, you can check. Use a calculator. Punch in this original expression. Punch in this final expression, and you'll see that these are going to be the same number. I feel like I did everything right. So let me go back and enter this, right? And it says, give your answer in a rational form, right? With fractions, do not use mixed numbers. What they mean by that is, I had the 65 halves here. What they mean is don't change that to a mixed number. Don't change that to 32 and a half. Right? Leave things as fractions. Leave things in rational form. That's what that meant. So I'm entering now, negative 65 halves times, and then next to it the square root of 2. And that should be all. Great. And once again, please read through your answer explanations. Alright, and then since there's only the one, each objective, if you're doing things correctly and not getting anything wrong, you should be only having to go through like 4 questions per objective if you're doing things right. So this should be the last one here for this one. Okay, so here we have one with variables involved. Notice that they're asking us to assume that the variable, right, the variable c, is greater than or equal to 0. The only reason they're doing this is so that you don't use absolute value symbols. You don't have to. Because remember, with even roots of variable expressions, our final results had absolute values sometimes, right? Just to ensure that you were given the non-negative root. But if the variable's already not negative, right, as they're saying here, you don't need absolute value symbols here. Okay? That's the only reason they're putting that instruction. Alright, so I'm going to write this out, and we'll do it on some paper. Alright. So 3 terms with a radical. They're all square roots, right? But they don't have the same radicand. Alright, so again, once off to the side here, I'm going to take each radical and we'll simplify it. Alright, now the square root of 50c squared. Pull off the perfect squares, right? Now that'd be 25 and c squared. Alright, those are perfect squares. Times, and then what would be left over, the square root of 2. And the square root of 25 is 5. Now remember, the square root of c squared would be the absolute value of c. But once again, up top here, they mention that c is not negative anyway. We're supposed to assume that c is not negative, so I can just say c instead of the absolute value of c, because it's not negative anyway. I hope that makes sense. Times the square root of 2. All right, so there's going to replace that first radical in the first term. And the square root of 98c squared. Again, break it off to the square root of a perfect square, which would be 49c squared, times the square root of 2. And the square root of 49 is 7. The square root of c squared is the absolute value of c, but c is not negative, so I don't need absolute values again. Right, so just 7c times the square root of 2. Right, so this expression will replace the square root of 98c squared in the second term. And we just saw the square root of 72 in the previous example, right, the previous question. And I broke this up to the square root of 36 times the square root of 2, right? And this is just 6 times the square root of 2, right? So this will replace the square root of 72. Alright, so let's do this. Alright, so this is kind of side work. Alright, so we have 4 times, and then the square root of 50c squared is replaced with 5c times the square root of 2. Minus, and then 4 times square root of 98c squared is 7c times the square root of 2. And plus, and then 4c times, and then the square root of 72 is replaced by 6 times the square root of 2. Alright, and putting stuff together, multiplying the numbers, we have 20c times the square root of 2 minus 28c times the square root of 2 plus, and then 24c, right, 4c times 6, 24c times the square root of 2, and then every single one of these has a square root of 2, so that's going to be at the end there. You can pull that out, and then you're just combining the coefficients, right? And these are like terms also. 20c minus 28c would be negative 8c, plus 24c would be negative 4c. All right, there you go. All right. Oop, no. Sorry. My apologies, that was bad. Yeah, we have negative 8c, and then plus 24 would be 16c. My apologies. So this ends up being 16c times the square root of 2. Right, after getting all the radical terms to be like, right, all have the square root of 2 attached, and then combining them, right, combining the coefficients. So this is what I'll enter. And if you want to test it out, just replace c with some non-negative number, say 1 or 2, whatever you want, and see if the original value of the original expression is the same as the value of the final one. And these should be the same value no matter what you replace c with, right, as long as it's not negative. Okay, let's go back and enter this. So we have a 16c. Be careful with the letter, right? Don't put an X or something. They got C in the problem. Times the square root of 2. And that should be good. Great. Alright, once again, please read through the answer explanations. Alright, and that should be it for this version of this assignment, right? This one objective. As I said at the top of the video, please understand that the questions you saw me working on here, may or may not be the questions that you're going to see when you work on it on your own. But the objective is the same. The types of questions are the same. They're asking you to do the same stuff. And the way I worked on them should be similar to how you're working on them as well. So I'm hoping that watching me do these helps you when you're working on the assignment on your own. And thank you very much for watching.